Today we are going to discuss BCS theory of superconductivity. As earlier I told you that superconductivity is a phenomena of some materials wherein the current passes through without almost without any resistance, or the resistance of the material drops to almost zero. This phenomena is called superconductivity, and the materials exhibiting this phenomena are called superconductors. So we discussed earlier the type of superconductors, that is type 1, type 2, and we discussed the effect of magnetic field on the superconductors, that is Meissner effect, wherein we came to know that superconductors not only exhibit almost a zero resistance, they also exhibit perfect diamagnetism. So these two properties combined together make a material or a combination of materials, that is type 2 superconductors. So the question arises that in a normal metal, or in a normal conductor, when we pass any current, and current, as you know, is the flow of electrons. So when we push the electrons with the help of a voltage, these electrons experience a resistance, and this resistance comes in two forms. One is the lattice vibrations, and that is the fixed positions of the atoms and ions, which is not 100% fixed. As you know, they vibrate around their mean position, and they generate vibrations. These vibrations are called phonons, and these phonons, these vibrations, kind of scatter the electrons, producing the resistance. Another important factor which contributes to the resistance is the scattering of electrons from impurities or defects in a conductor. Then the question is that why it does not happen in case of superconductors? Why the electrons are not repulsed, does not scatter in a superconductor? So, to explain this phenomena, a very basic theory, which is more a qualitative theory than a quantitative one, was developed by three scientists: John Bardeen, Leon Cooper, and Robert Schaefer. This theory, after their surnames, is combinedly called BCS theory, Bardeen Cooper Schaefer theory of the phenomena of superconductivity. It is uh, it can be said as the first attempt to explain the phenomena of superconductivity, or phenomena of zero resistance offered to the electrons. So, in this theory, the basis of this theory is the formation of a pair of electrons, that is called Cooper pair. Cooper pair is a pair of electrons which are weakly attracted to each other. So this, at first sight, this sounds very counterintuitive, because as you know that electrons, being the same charge, we have studied that they repulse each other. There is repulsion between like charges. But in this pair, in this Cooper pair, the electrons are weakly attracted. So they form a pair, and this pair glides through the superconductor without much resistance, almost negligible resistance. So the first is that how this pair is formed. So in this figure that you can see, these are the fixed uh, positions of atoms, lattice, crystal lattice, and when an electron approach this lattice, so electron being the negative, it pulls some positive ions towards itself. So there is formed a region of, you can say, more positive charge around that electron. You can find an analogy of this phenomena. Say, for example, if there is some accident happens in the on the road, you see that people gather around that uh, for some time. Afterwards, they may disperse when the situation normalizes. So something similar happens when electrons comes into a part of the crystal lattice. Some positive ions are more displaced towards the electron. This uh, displacement forms a temporary region of positive charge, more positive charge, and the another electron coming behind that first electron sees this excess positive charge. It does not see that electron, like you do not see the person who is injured in a crowd. So it sees the electron. It does not see the electron there. It experiences a more positive charge there. So it is attracted towards. In the same way as you, when you see a crowd gathered around something, you do not know what is there, but you somehow, out of curiosity, you want to see that what is there. So you kind of attracted. So this second electron is attracted. So in a sense, the first electron and the second electron, they form a an invisible bond, and they form a Cooper pair. This is called Cooper pair. So as the first electron keep on moving, the second electron follows it. So the second electron is not exactly following the first electron, it is following the charge distortion that is produced by the first electrons. And afterwards, when they cross the excess positive ions which came closer from their mean position to the first electron, they regain their position. But this pair is formed, and this pair glides in this way through the whole material. So this is the basic explanation of the uh, this formation of Cooper pair. And this Cooper pair glides when the resistance, because the temperature is low. Most of the superconductors, work on the less temperatures. So this other phenomena of scattering, uh, thermal scattering, is mostly absent. And this Cooper pair, in this Cooper pair, the electrons are uh, bound by the delayed attractive force, that you can say. And the thing is that from the BCS theory, the total linear momentum of a Cooper pair zero. Must be zero. Uh, it means that they travel in opposite direction. Uh, in addition, the nominal separation between the Cooper pair, which is also called coherence length, ranges from hundreds to thousands of ions separating them. So it's not very small distance. They may range from few atoms, few hundred atoms to, or ions, to thousand or hundreds of ions. And this is a quite large distance. Because if the electron come very close, if the electrons come very close, they will start experiencing that electrostatic repulsion. So they do not come very close, and they maintain a particular distance. At whatever distance they have been bound in a pair, they maintain that distance. So this is the basis of uh, BCS theory. So I suggest that you read these notes, and we will discuss whenever we meet any of your doubts and questions.